Okay, so chapter 7, we're going to get into this thing called array and array lists. So let me open up this. And basically, so you can see we got 14 different sections we're going to cover tonight. And we're basically, bottom line, it says an array can hold multiple values of the same data type simultaneously. So let's do this first. Let's go out here to Eclipse. Let's go to Google Classroom and let's go to classwork and files needed for lectures, source code, and then source code, and then we're going to come over here to the right hand side. We're going to download chapter 7, and mine automatically goes to my downloads folder. And then I'm going to open up Eclipse and go to File, Import. And under the General, we're going to click Existing Projects into Workspace. And Next. And then we're going to grab, I'm going to go over here to Downloads. I'm going to grab Chapter 7. And I'm going to click Finish. And now I have a chapter 7 over here. Did you get it? Okay. You probably already had it, didn't you? I bet you did. Okay. So an array is, here's the analogy I like to use. Think of an array as we're going to build a bookcase, and then we're going to basically then build shelves. So think of the bookcase as one item, and then we can actually say, hey, give me item off of shelf number 2, give me item off of shelf number 3. That's basically kind of what an array is, okay? So if we look over here on page 404, it basically says, okay, here's our bookcase, and we can tell it how. So the first thing we'll do is we'll build the bookcase, and then the next thing we'll do is we'll tell it how many shelves it's going to have. Now here's the thing about arrays. Once you say how many shelves it's going to have, we cannot change that. I cannot remove a shelf or add a shelf. It's stuck with all those shelves. When we get to this thing called array lists, those we can then modify. So an array is immutable, meaning it cannot change. Once you set it and create it, it cannot be changed. So right here I basically have now each numbered shelf, the first shelf number is going to be 0. So we always start at 0. So we have element 0, element 1, element 2, 3, 4, and 5. So this is a 6-element array. And again, 0, 1, 2, 3, 4, 5. Kind of like we've done with the for loop. So how do we declare an array? Well, the very first thing we do, it's kind of like an object, where we say int, left and right, square brackets, numbers equals new int 6. So on this side over here, on the left-hand side of the equal sign, this is where we build the bookcase. So the bookcase has been built. It has no shelves. On the right-hand side, we say equals new int 6. That then puts in 6 shelves. And they're automatically numbered 0 through 5. So here I create a float temperatures. Again, on the left-hand side, the empty bookcase is created. On the right-hand side, we just put in 100 shelves, labeled, numbered 0 through 99. Here's a char, letters, char 41. Okay, so you kind of get the gist here. On the left-hand side, we have empty square brackets. On the right-hand side, we tell it how many shelves we're going to have. Okay. So let's do this. Let's go ahead and open up Array Demo 1, and let's take a look at it. So in here, inside of my public static void main, I've created a constant called employees. It's an integer, and we've set it to 3. over here I've got int, left and right square brackets, so I'm telling it that I'm building an array. I don't know how many shelves I've got in it, so it's an empty bookcase on this left side. On the right hand side, I'm going to instantiate it as a new array, and I'm going to then apply it with 3 bookshelves. I got a scanner keyboard, and then I'm going to print, enter the number of hours worked by employees. In this case, it's going to say 3. And then I'm going to say print employee 1 hours 0. Now this is how we load an array. I say the array name, and then I say what position or what bookshelf I want to put this on. For bookshelf 0, I want you to basically type in an integer. It's going to grab it from the scanner keyboard and then throw that into that element. Next one I say employee 2, we're going to put this in bookshelf 1. Employee 3, we're going to put that in bookshelf 2. So there's bookshelf 0, 1, 2, 3, 0, 1, 2, excuse me. 0, 1, 2 is going to basically have 3 different integer amounts inside of them. They could have the same amount, but and then we're going to then display it by saying the hours you entered are hours 0, hours 1, and hours 2. So let's run this to see what it looks like. And hours, we're going to go ahead and type in 40. Employee number 2 will type in 20. And employee number 3 will type in 15. And then it comes back and says the hours you entered are 40, 20, and 15. So here's what's kind of nice about an array is it's one blob sitting there, and it can hold a whole bunch of different data. And all we have to do, we can refer to it by its name of hours, but then we have to tell it which box we're pulling that out of, which bookshelf. So any questions? Sure. Yeah, it's kind of like that. It's kind of like it's like a box. And again, the box has a name, and we're always going to refer to that box by the name. But then inside that box, it's got different sections, and each one of those sections is automatically numbered. And we can put stuff into that box, and then we can pull stuff out of that box. And again, we always refer to it by its name of, in this case, hours. In this case, it's got 3 different sections of that box. So when I grabbed employee number 1, I put that into the 0 section. When I got employee number 2, I put that into the number 1 section. When I did number 3, I put that into the number 2 section. And then I can then pull data out from section 1, section 2, section 0, and basically, so again, it's kind of a nice way. It's kind of a nice way to put everything inside of one box. And I only had to declare one item here. I just had to declare hours right here, and I'm able to put 3. I'm able to put 3 different numeric values in it. If I'd have made this into 5 or 6 or 7, even 100, I could have done that too. Now I have a box with 100 different sections in it. Does that answer your question? Okay. Now, the way we used it here is probably not the most efficient way to use an array. Probably the most efficient way to use an array is to utilize it with some type of looping process, and we'll see that here in a little bit. Let's take a look at array demo 2, though. And this is where we get into the using a loop process. So this first part here is identical to the previous one, except that in this case, we're going to use a for loop to get data from the user, and we're going to use a for loop to display the data. Okay, so I've got my constant, I've created my array, I've got my scanner keyboard, then I'm going to say enter the hours worked by employees, employee. Then I've got for int index equals 0. Again, that gets executed only once at the very beginning. And this is the check at the beginning of every loop, while index is less than employees. In this case, employees is 3, and index is 0 right off the bat. So 0, that's true. At the end of every loop, it's going to add 1 to the index. It's going to then say employee index plus 1. Again, we want to do employee 1, 2, 3. If we didn't add 1 to index, it would say employee 0, 1, and 2. So we add 1 to the index so it displays 1, 2, 3. And then we go ahead and grab the from the keyboard.nextInt. We throw that into hours index. Look at that. The index is 0 first time through. At the loop, we add 1 to it, and we come back around. Index is now 1. Index is now 2. And when index gets to 3, is 3 less than 3? No, that becomes false and it drops out of the loop. Then it displays the hours you entered are. Now we've got another for loop. Again, we create another index, integer index, set it to 0. Well, index is less than employees. We're going to display hours index. So we should see the same exact thing we saw in the first one. We should see the same thing for this one as well. So let's run it. And if I type in 40, then 20, then 15, it says the hours you entered are 40, 20, and 15. So as you can see, there's a big difference. I mean, look at all the code. Whoops, I want to do that. Look at all the code for, we've got 40 lines of code for this guy, but for Array Demo 2, we only have 34. So we didn't, and here's another thing too. With Array Demo 1, what if I increase this to 6? Okay, I'm going to increase the employees to 6. So let's run it. And it's going to say employee 1, 40, employee 2, 20, employee 3, 15, and then it says the hours you entered are 40, 20, and 15, but it says enter the hours worked by 6 employees. Whoa. This guy is made for 3 employees only, but if we go to the Array Demo 2, it's dynamic, meaning that it will basically display, if I change this to a 6, and I run this, I can then type in 40, 20, 15. Oh, look at that, employee number 4. They worked 18, 36, and 25. And then it basically says the hours you entered are, and then displays all of them. So this guy is dynamic. It will basically grow to how many type employees that you type in this constant right here. So that's the great thing about using for loops, is it doesn't restrict us like the first program did. Any questions on that? Now, let's take a look at this one called invalid subscript. And if we try to run this, we are going to get an error. And it basically says we had an exception thread. It says index 3 out of bounds for length 3. So what is the problem here? Well, I've created an array called values. It's got 3 elements in it. So basically it's a bookshelf with 3 shelves. And then I will attempt to store 4 numbers in a 3-element array. So right here, int index equals 0. So we've initialized the variable index to 0. And while index is less than 4, so that means it's going to go 0, 1, 2, and 3. That's 4 elements it's going to try to put in this array, and this is where we get the index out of bounds. That's saying that this array has only got enough room for 3 elements, and you're trying to put 4 in there. 0, 1, 2, and 3. So if you ever see this index out of bounds, that's basically what that means, is you tried to go out of the bounds of the array size that you have right now. Now, we can create an array and put data into it at the same time. So let's open up array initialization. And there we have int, left and right parentheses, days equals left brace, 31, 28. There's basically 12 different numbers there, and then a closing brace. You notice we didn't have a square bracket of 12 in there. We didn't have to, because these brace says, hey, go ahead and throw these 12 numbers into that array, and it automatically creates the size. It automatically puts 12 bookshelves in my bookcase automatically, and automatically puts each one of those numbers on a bookshelf. Then I've got for int index 0, and while the index is less than 12, we're going to display month index 1, because again we want it to say month 1, 2, 3, 4, all the way up to month 12. If we didn't add 1 to the index, it would say month 0 all the way through month 11, and that wouldn't be right. So we're going to say month, whatever number that is, has that many days index. So days index is going to open up this days array, and whatever number's in there, it's going to pull back that numeric value. So there's element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we run it, there we say month 1 has 31, month 2 has 28 days, month 3 31, all the way through month 12 has 31. So we can initialize building an array right off the bat. I can say int days, and then basically load it by putting the braces. I have to use braces, and I have to put commas, separate them with commas. Any questions on that? Okay. I'll take the silence as a no. Now, on page 412 of the book, it does say we can do this. I can just declare an array, an empty array. I can say int, left and right square bracket numbers, or I could say int numbers, left and right square brackets. These two things are going to do the same exact thing, okay? Or down here I can say int, left and right square bracket numbers, codes, scores, or int numbers. Now, if you look at this, is that going to be 3 different arrays? No, it's actually only doing this first item is only the one that has the array to it. The rest are just integer data types, primitive. To do that, we would have to basically, oh wait, I'm sorry, this will create an array of 3. This will only create an array of 1. If we wanted to do it this way down here, we would basically have to do each one of those separately. So as you can see, this way is a little more efficient than basically doing it this way. It's probably best practice to always put it with the data type that we're basically creating, is to put the square brackets to that and not the variable name. But the book's trying to let you know that you can do it this way and it's perfectly legal. But you can see that there could be some issues between this and this. You got to type some extra square brackets to do that. Okay, so let's open up pay array. Payarray.java, and there I've got a final int, so I've got a constant called employees, and I set it to 5. I've got a double pay rate, and I've got a double gross pay. I create an array of employees, or hours, so I've got an array of hours. So I've got int, left and right square bracket, hours. On the right-hand side, we're going to basically then instantiate it with 5 bookshelves, so 5 elements. It's empty right now. Each one of those boxes is empty. Then I create my scanner keyboard. Then I want to print, enter the hours worked by how many employees we have, 5, who all earn the same hourly rate. So in this particular case, everybody in this array makes the same amount of money. I use a for loop. I say for index 0. While the index is less than employees, we're going to go into this guy, and we're going to add 1 to the index at the very end. So I print employee, again, index plus 1. We want to say employee 1, 2, 3, 4, 5 instead of 0, 1, 2, 3, 4. So employee, whatever that number there is, hours index, so it's going to grab whatever that index is. It's going to grab that box, and we're going to take whatever we type in this next int for the keyboard. It's going to be put into that element of that array. So once that's done, we now have an array that has hours for each employee, each of the 5 employees. Then we're going to ask you to enter the hourly pay rate for each employee. And again, remember, they all make the same amount of money. And then we're going to do each employee's gross pay. So again, we're going to go in the same exact loop. We're going to say gross pay is equal to hours index, whatever we typed in their hours, multiply it times pay rate, and then we're going to display employee number, again, index plus 1, is equal to $, whatever that gross pay is. And probably the best thing, we probably should have used a dollar format there, so that we would have basically could have got it down to 2 decimal places, but we didn't. So let's run this. And we'll say that I went too far. So employee 1 worked 10 hours, employee 2 worked 20, employee 3 worked 30, 40, and then 50. And then we're going to say they made, let's say they make $10 an hour. So employee 1 made $100, employee 2 $200, $300, $400, and then $500. And again, what's nice about this is we could actually change this number of employees to 6, and this would run just fine, since we're using a loop process as opposed to just individualizing each item. So any questions? Okay. So on page 416, talks about the enhanced for loop and how that works. So page 416, we have the enhanced loop. And here's the format for it. We say for, except this time we say the data type, and we create a new element, a new variable, and then we say the array. So if I have int numbers equals 3, 6, and 9, the enhanced for loop looks like this. I say for int val colon numbers. Here's how this is going to work. It says automatically, this is really cool how it works, it's automatically going to pull the first element out of here and put it into val. We're going to then say print val, it's going to print a 3. The next time through the loop, it's going to grab the next element and put it into val. It's going to say then print, it's going to print 6. Next time through, it's going to grab the next element, which is 9, and put it into val. It comes in here and it's going to print 9. It comes back around, it tries to grab the next element. It says there's no more elements. It automatically drops out. So man, this looks a lot more efficient. This for loop here looks a lot more efficient than what we've seen with the other for loops. The only problem is, again, this is a great way. So we could have done this. Let's do this. Let's go back in here. And this for loop right here, I'm going to comment it out. yeah, you want to follow me, you can, or you can just watch. So I'm going to comment that. Not in Python. I'm going to comment that out. I'm going to say for double val no, I can't do it. Sorry. I just broke one of the rules, and I'll show you why. Yeah. Here's why. On page 417, it says the enhanced for loop versus the traditional for loop. You cannot use an enhanced for loop as follows. If you need to change the contents of an array, can't use it. If you need to work through the array elements in reverse order, can't do it. If you need to access some of the array elements but not all of them, can't do it. If you need to simultaneously work with two or more arrays within a loop, can't do it. If you need to refer to the subscript number of the particular element, that's why I couldn't use an enhanced loop for this, because I'm using the index right here to show the employee number. But I could do this. I could say for double, how are they doing this? Yeah, double val, and then I'm going to say is ours double? Ours is ours is an int. So I'm going to say int val colon hours SYSO, and I'm going to say val times pay rate. So it's just going to multiply the value of each item and put in the pay rate. So again, if we run it, and I'm going to type 10, 20, 30, 40, and 50, and the hourly pay rate is 10. So look at that. So it did 100, 200, 300, 400, 500, and look what it did down here. It took the val, because what it does is it, as we step through this for loop, it grabs the first element, throws it in the val. We deal with it. When it automatically comes back around, it automatically grabs the second element, puts it into the val. And it keeps doing that until it's all out of elements. This one seems, this for loop up here seems a little more easy to read because we can see what's going on. We're saying while this is true, we're going to go into it. This, on the other hand, is it'll kind of set you back a little bit because you kind of look at it and go, whoa, 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 int val. Again, I can make this val I could have called it hour. That'd probably been the better thing to do is call it hour. Int hour, and then so again, it's going to grab each element, throw it into this variable each time it goes through the loop. Does that make sense? So again, the rules are if you need to change the contents, can't do it. If you need to work through the array elements in reverse order, because we could do this. I could do this up here. I could say index equals employees, and then over here I can say I can actually say index minus minus. Let's see if that works. No, I screwed up. It's not going to work. I need to say index is less than employees. Now I'm going to say, well, index is greater than 0. I'm going to say greater than or equal to 0. There we go. Now run it again. So 10, 20, 30, 40, and 50, and they make $10 an hour. Say that'll work. So 10, 20, 30, 40, 50. Yeah. So see that? Started at 500. We went backwards that time. We went 5, 4, 3, 2, 1. Can't do that with an enhanced for loop. Enhanced for loop is it goes to the first, second, third, fourth until it has no more elements in the array. And then it's done. Okay. Let's open up display test scores. So now this is where it gets kind of different, is we say int num tests and int left and right square bracket tests. We just created an empty bookcase. We don't know how many shelves it's got. Okay, so now what do? Well, we create our scanner keyboard, and then we're going to ask, how many tests do you have? And we're going to grab that from the keyboard next int, throw it in the num test. Now look what we do. Tests up here, I'm going to say test is equal to new int num tests. This is where I then, so up here I created an empty bookcase. Down here I add the number of shelves. I didn't know how many shelves to add until I know I got that data from the user. So this is kind of nice. We can create the array with no elements and then add the number of elements later on. That's perfectly legal. And then we're going to come in here and enter the test scores, and we're going to grab them each individually from the user, depending on how many test scores we wanted to get. And we're going to basically add that to each test element via this index within our for loop. And then we're going to say, now I think this is a perfect opportunity that we could use the enhanced for loop. Let's see if that'll work. So if I basically come down here and do for is it, what's test? Is that it's int. I say int test colon tests, and then I can't do, that's right. So I'm just going to say print test. So perfect opportunity to use an enhanced for loop right here. So let's run it. And I think they want us to enter 5. And test score 1 is a 72, an 85, 81, 94, and 99. And then when I hit the enter key, it says here are the scores you entered: 72, 85, 81, 94, 99. So if you kind of look at these two for loops, you can see that this enhanced for loop is a lot cleaner than the old for loop. But again, remember the restrictions. Restrictions are it's just going to grab each element one at a time and put it out there. So any questions on that? exactly this. I am recording these, and I will put the recording out there if you want to basically kind of watch this at your leisure. Uh-huh. Okay, that's fine. That's fine. Yeah, so if you want to watch this after the fact, that'd be fine. So, okay. Now on page 420. Oh, wrong one. On page 420, we wanted to copy an array. Okay. So I've got this array. I've got array 1, and I initialize it to 2, 4, 6, 8, 10. And then I create array 2, and I'm just going to make it equal to array 1. Okay? I just copied it, right? Well, actually, no, I didn't. Here's what it did. Is it took the address of array 1 and put it in array 2. So what we have now is an array with 2 different labels. And let's see what that looks like. Let's open up same array. So here we've got int, left and right square bracket, array 1 is equal to 2, 4, 6, 8, 10. So here's an array with 5 elements. And then I say array 2 is equal to array 1. Here I say array 0, I'm going to change element 0 to 200. It's no longer 2. Array 2, I'm going to change element 4, which is the 5th element. I'm going to change that to 1,000. Then I'm going to go through, I'm going to use an enhanced loop to display all the values of array 1, and another enhanced for loop to display all of the elements of array 2. And let's see what happens. 200, 468, 1000. 200, 468, 1000. Again, they aren't 2 separate arrays. They are the same exact array with 2 different name tags. They have the array name tag of array 1 and the name tag of array 2. So that's all that happened right here on line 12, is it just copied the address of array 1 and put it in array 2. So they're both pointing to the same exact array. Let's see here. Okay, let's do this. Let's go to page 486, and let's do the rainfall class score for 12 months. Okay. So, so it says, write a rainfall class that stores the total rainfall for each of the 12 months into an array of doubles. The program should have methods that return the following: the total rainfall for the year, the average monthly rainfall, the month with the most rain, and the month with the least rain. Okay. So demonstrate this class in a complete program. We're not going to worry about the validation. Do not accept numbers, negative numbers. Okay, so let's come over here and let's create a new project. We're going to click File, New Project, and it's going to be a Java project. And we're going to call this Chap 7 Labs. Chap 7 Labs. Let's click Finish. So now down here we should see a, let's see, there it is, Chap 7 Labs. I'm going to expand that. I'm going to do a right click on the SRC folder, point to new and package, and let's just call this Labs, all lowercase, and we'll call it finish. And then we're going to do a right click on Labs, point to new and class, and we're going to call this rainfall. And make sure we put a check mark in public static void main. And let's click finish. Okay, so we have our class ready to execute. So it basically says, okay, we need to have an array and write doubles. So let's do this. Let's do double left and right square bracket. And we're going to call this rainfall. It's going to be equal to new double left and right square bracket. And we're going to put a 12 inside of that, and then a semicolon at the end. So now we have our array built. Let me know if I'm going too fast. And then I'm going to just create a scanner keyboard. Uppercase S, scanner. Sure. A rainfall is an array. An array is basically, it's an array. So think of it this way. Think of it, so on the left-hand side of that equal sign, we are going to create an empty bookcase that has no shelves. Okay? On the right-hand side, we are now adding the shelves. It's adding 12 shelves to it, and they're automatically numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So, back to page 423, we're going to talk about passing arrays as arguments to methods. And we just saw that here. Remember when I passed double rainfall? So we pretty much already just covered that. So we can pass an array as a parameter to a method. So let's open up, I'm going to open up Chap 7. And what I'm looking for is pass elements. .java. Hold on just a sec. No one wants to hear a barking dog. Okay, so we look here, I've got INT numbers. Again, I'm initializing this array with 5, 10, 15, 20, 25, 30, 35, 40. And then I'm going to say for index. And then I'm going to say show values numbers index. So this is going to pass each element one at a time. What we saw in the previous one, the rainfall, we basically passed the entire array. So here we're going to pass the numbers index. We're going to pass each element one at a time down here to show value. So it's going to receive an integer and not the entire array. So I system.out.print in and then a space. Notice it's doing a print. That means it's going to print side by side. So when we run it, and we got a space, so it's got a space after it. So there's 5, space, 10, space, 15, space, all the way up to 40. And there is a space after 40 because it prints a space after each number. So we can pass each element just as a value to a method, or we can actually pass the entire array itself. Yeah, so let's see how that works. We got passArray.java. So here's passArray, public static void main. We go ahead and create a constant array size equals 4. So there's our constant of 4. And then I create my array. It's int numbers equals new int array size. So remember, on the left-hand side of the equal sign, this creates an empty array. This is the empty bookshelf. On the right-hand side, we add the number of shelves. How many shelves? 4. So when we get through with line 16, we have an array that has 4 boxes in it. Then I'm going to say get values numbers. So here I'm passing the entire array to this method get values. So down here is get values. Notice it's got int, left square bracket, right square bracket, array. Because remember, we're passing by value. We're not passing the actual array, we're passing the value. So we have to recreate an array down here, and we have to initialize it as an int equal array. So now I got my scanner keyboard. Here I do I enter the series of array length numbers. Now, here's something new. I think I missed that. But each array has an, a method built into it called length. So if I do a period right here, these are all of the different methods that come with it. One of them is called length, and that will give us the number of elements in the array. So that's kind of cool. So this says a series of, now how many elements are in there? Well, there's 4. So array.length is going to print the number 4. So let's go enter a series of 4 numbers. So we got another for loop. So now look at this. Index, well, the index is less than the array.length. What's in the array.length? The number 4, because there's 4 elements in that array. We're going to enter index plus 1. So again, we want to say 1, 2, 3, 4. So enter number 1, enter number 2, enter number 3, number 4. We don't want to say enter number 0, enter number 1, enter number 2, number 3. And then we're going to say array index is equal to keyboard next int. So we actually load the array right here on line 48. So any questions on that? Now, after we get done, we say here are the numbers you entered, and then we call show array numbers. So we come down here to show array, and again we're passing an array, and down here we now again, I don't know why they keep using a for loop and not an enhanced loop. We could do this. We could do for int. I'm just going to call it A, colon, array, and then I'm just going to do my SYSO, A plus double quote. Again, I'm going to comment these 2 lines out. There's no need to go through all of this stuff when we can just say use an enhanced loop to basically get the data. We're just going to get the same exact stuff. So now when we run this, it says enter a series of 4 numbers. Let's go ahead and type in 2, 4, 6, 8. And it says here are the numbers you entered, 2, 4, 6, 8. And again, I can comment this out and uncomment that and get the same exact results. Two, 4, 6, 8, and there's 2, 4, 6, 8. So any questions on that? So a couple of new things was introduced. Number one was the dot length. The dot length is very, very important because it saves us from doing this. It saves us from saying index less than array dot length. Well, I could have done this. I could have done the array size, but we don't need to know the array size when we have the dot length. The dot length is going to tell us how large that array is, how many elements are in there. Any questions on that? Okay. On the bottom of page 426, top of page 427, they talk about comparing arrays. How would we compare arrays? Well, they have the code there, but they don't have an example to use. So I went ahead and wrote that out. Let's open up comparearrays.java. So here we've got two arrays, first array, second array. They both have 2, 4, 6, 8, 10. So each have 5 elements. I'm going to create a Boolean variable called arrays equal. I'm going to initialize it to true. I initialize the index equal to equal 0, the int index. And then we're going to say if first array dot length is not equal second array dot length, I'm going to say arrays equal false. Then it says while arrays equal and index is less than first array dot length, we're going to go into that loop. If first array, the index, is not equal to second array index, the arrays equal false. And we're going to add one to the plus sign. So as soon as this index is greater than the length of, or it's equal to or greater than the array dot length, the number of elements in the array, we're going to drop out of that loop. Now, if this guy stays true, so if arrays equal, we're going to say the arrays equal, else the arrays are not equal. So basically what we're doing is we're going through one element at a time for each array and looking at see do they equal. So anytime this arrays equal is set to false, we're going to drop out of this array, and that's going to cause this to print. So if we run it, it says the arrays are equal. I'm going to change this 6 right here to a 5, and I'm going to rerun it, and it says the arrays are not equal. Because when it got to this one and it got to the number 0, 1, 2 elements, the number 2 element, it basically saw that 6 and 5 do not equal, and it basically caused this right here to be false. It dropped out of the loop, and when it got to here, that was false, and it displayed that guy right there. Any questions on that? Now, over on page 428 or 429, this is where we get into the finding the highest and lowest in a numeric array. So if we come over here to sales data, let's see what they do. I've got private double sales, and I've got public sales. So look at this. This is not a public static void main. This is a sales data class. So this is a class all by itself. So we've got an instance variable. And look what our instance variable is. Our instance variable is a double array called sales. Here's our constructor. This is going to be executed when the class is instantiated. It's expecting an array of doubles to be passed in. It's going to be called S. So up here we created an array. Down here we're going to say sales. See this? Right here, when this line 11 executes, it creates an empty bookshelf. It has no shelves in it. Down here on line 22, we take the number of shelves that's in S, and we set that number of shelves in the sales array. So sales equal new double S dot length. Then we say for index 0, while index is less than S dot length, we're going to say sales index is equal to S index. So look at this. We are making a true copy of an array. I'm passing in this S array, and it's taking each element one at a time and placing it into sales element one at a time. So when our constructor executes, we now have an array inside that's a instance variable is going to be loaded with data. Here I've got get total. We've got double total, 0.0 for index. So basically we saw this on our rainfall. Total plus equals sales. So it's going to basically go through this sales array one at a time and add that to total. And when we get done, it's going to return the total. Here we've got public double get average. So the double says it's returning a double. Here I've got return get total. It's going to call the get total up here divided by sales dot length. So here's what's nice about this. It doesn't care how many elements you have in your array. The dot length always knows how many are in there, and we can then divide by the number of elements in the array to get our average. Now, here's our get highest. It's got double highest equals sales 0. So the very first element of the array we're going to put into highest. Then we're going to go through the array one at a time. But notice what we're starting with. We're starting with a 1. Why is that? Well, since we've already taken the very first element and put it into highest, we're going to start with the second element, the element in the number 1 position. So 0, then 1. And what we're going to do is we're going to say if sales index is greater than highest, so if the number 1 element is greater than the 0 element, we're going to make a highest equals to that particular sales element. We're going to keep doing that. So when we get through with this for loop, we're going to know which element in that array is the highest because it's going to be on the highest variable. We return highest. So whoever calls get highest, it's going to be returned the highest value inside there. So what do you think get lowest does? Pretty much the same exact thing. We grab the very first element of the array, we put it into lowest. We go into the for loop to go through each element one at a time, and this time I'm saying if sales index, if that element of sales is less than lowest, we're going to then move that element to lowest. So when we get through with this for loop, lowest is going to show us the lowest value of the element in that array. Now let's open up sales, and here's our public static void main. I create a constant of 7. I create an array, a double array called sales, and then I set the number of bookshelves, the number of elements, I set to 7 because of this 1 week right here. Then I call get values and I pass that sales. So it's going to come down here to this get values. Here's the array. we then string input, and we're going to ask the user to, via a J option pane, we're going to have them enter an element for enter a data for each element of that array. And then notice we've got void here. Why? Because we've passed in that array, and it basically gets loaded up, via here. Then here's where I create my object. I'm going to create a week object. It's a sales data object. I'm going to instantiate it as a new sales data, and here's my constructor. I pass in sales. I pass the array sales as my constructor, so that right here in my constructor, there's the array. That's where it loads up this instance variable, which is an array. Then here's my decimal format dollar, because I want it to basically have it comma separated and have it round to 2 decimal places. Then I'm going to do a J option pane. The total sales of week dot get total. So it's going to basically take this object week. It's going to call the method get total. It's going to call the method get average. It's going to call the method get highest and call the method get lowest, and then it's going to exit out of that class. Stop the run. So it's going to ask us for data. So let's run this. And sales for day 1, we're going to say is 1,000. Sales for day 2 is 2,000. Sales for day 3 is, we're going to say 3,000. Sales for day 4 is 4,000. Sales for day 5 is 5,000. Sales for day 6 is 6,000. And sales for day 7 is 7,000. Click OK, and look at this. It comes back and says the total sales were 28,000. The average sales were 4,000. The highest sales were 7,000. The lowest sales were 1,000. It's pretty cool stuff. So this time we're using a class. We created a class, and in that class we have, hey, get the total. Go through that array, add them all up, and give us back the total. The get average says, hey, call total, get the total amount, divide by the number of elements on array, and that's going to give us the average. The get highest says I'm going to go through there one at a time, and if the element is greater than the highest, make that the highest. It's going to keep doing that. So when we get through with that, the highest has the highest value in there. Same way with lowest. It's going to basically put the lowest value in there. Any questions on that? Okay. On the bottom of page 433, we've got creating an object that processes an array. It says Dr. LeClaire gives you a set of exams during this semester in her chemistry class. At the end of the semester, she drops each student's lowest test score before averaging the scores. She has asked you to write a program that will read the student's test scores as input and calculate the average and the lowest test score with the lowest test score dropped. The following pseudocodes are the steps to calculate the average of the set of test scores with the lowest dropped. We calculate the total scores. We find the lowest score, we subtract the lowest score from the total. This gives the adjusted total amount. Then we divide by the adjusted total amount, which is the total number of scores minus 1 since we threw out the lowest, and that's going to be the average. So, top of page 434, there's our UML diagram. There is our grader class we're going to create. It's going to have an instance variable called test scores. It's a double data type. And notice it's got the square brackets. It's an array. We've got our grader score array double. So the grader is going to be our constant since it's got the same exact name as the class itself. The name of the variable being passed in is called score array, and it's a double, and it's also, you can see square brackets, it's an array. We're going to have a method called get lowest score. It's going to return a double. We're going to have another method called get average, and it's going to return a double. So let's open up the grader. Where is it? Grader, G. Oh, there it is. Let's open up grader. So here's the grader class. Here's our instance variable, test scores, double. Notice we have not set the number of elements in there. Here is our constant. We're bringing in a score array, and this is where we make test scores equal score array. Ooh. Remember, when we do that, we're just copying the address. So test scores is basically the score array. These two things are identical. They're both pointing to the same exact array. Is that a good thing? I'll tell you what's bad here in a second. Okay, we've got get lowest score. We pretty much went to how that's going to work. We got double lowest. We go ahead and make lowest equal to the very first element, and then we start at the second element and go through and see if each element is less than the previous one. When we get done with that, we're going to return the lowest score. We've got get average. We're going to have three local variables for this method: total, set to 0, lowest, and average. If test score.length is less than 2, it says error, you must have at least 2 test scores. And we're going to set average equal to 0. Else, if the length is greater than 2 or equal to 2, we're going to say 4 double score test scores. We're using an enhanced for loop. It's going to grab each element out of this array and throw it into score. Total plus equal scores. When we get done with that loop, we have a total. We're going to say lowest is equal to get lowest score. When we get done with that line, we're going to have the lowest test score. We're going to say total minus equal lowest. We're going to subtract the lowest test score from the total. Then we're going to say average is equal to total divided by test score length minus 1. Because since we've thrown out the lowest score, we're not going to add that to, we're not going to divide by the full number of tests, because we threw out 1, we're going to subtract 1 from it. Then we're going to return average. Any questions on that? So let's open up calc average. So here's our public static void main. We're going to create a local variable called int num scores. We're going to create a scanner keyboard. We're going to, how many test scores do you have? We're going to get that from the scanner keyboard and throw it in the num scores. Then we're going to create an array called scores. That's a double. We're going to instantiate it with the number of scores we typed in up here. So basically, when on this side of the equal sign, we create an empty bookcase. On this side, we then add the number of shelves. How many shelves? Whatever we typed in here. Then I got my for loop. We're going to basically go through this array one element at a time and ask the user to enter in a test score. So when we get done with this for loop, we're going to have an array full of data. Now, on line 38 is where we create our object. We're going to create a grader object called myGrader. We're going to instantiate it with this array scores. Then we're going to print ln your adjusted averages myGrader.getAverage. And then on this side, we're going to say your lowest test score was myGrader.getLowestScore. So once we get this array loaded, then we create our object, and this is going to call our constructor, which is going to load the array, or make, I won't say load because it just says that is equal to that. We get so we get our average, get our lowest. Now I want to back up a little bit. Remember I said doing this is probably not the best thing. Why is that? Well, guess what? If I change the scores array over here, it also changed it over here, because remember, these are pointing to the same exact array. So probably not a good thing. The way we did it in sales was probably the best way to do it in sales data, where we went through and took each element out of the array and made a copy of it. And this, so when we get through with the sales data class, we truly have a copy of the array. Over here in Grader, we don't. Okay. So let's go ahead and run. Let's go ahead and run the calc average. And how many test scores? Let's go ahead and enter 4. And test score 1 is 100. We'll say 150. We'll say 40. And then we'll say 100. And it says your adjusted average is 116.66667. Your lowest test score was 40. So if we add those three up, 100, 150, 100, that's 350 divided by 3 is 116.66666. What do you think? Pretty cool? Let's open up return array. And return array is kind of wild, because look at this. In our public static void main, I've got double left and right square bracket values. So here I've created an empty array. It has no elements in it. There's no shelves. There's no shelves in my bookshelf. Then I'm going to say values equals get array. Wow. So that's a method. So come down here, and here's get array, and it's going to return a double left and right square brackets. So it's returning a double array. So look at, we got double left and right square bracket, array equals 1.2, comma, 2.3, comma, 4.5, comma, 6.7, comma, 8.9. So 1, 2, 3, 4, 5 elements in this array, and then we return the array. So when we get done with this, we now have an array of 5 elements. And then I can use an enhanced for loop and say for double num values. So it's going to grab each element one at a time and throw it into num, and then we print num and then a number. We're doing a print, so it's going to print them side by side. So we run it, and there it is. 1.2 space, 2.3 space, 4.5 space, 6.7 space, 8.9 space. So look at that. I created an empty shell of an array. I say values equals get array. It goes ahead and initializes that to a double. Initialize it as doubles and puts it into array, a return array, and it takes this array and shoves it into values. Any questions on that? Okay. Now on page 441, so up to this point, all we've done is create primitive values that make up arrays. Can we do it with strings? Can we do it with objects? We most certainly can. So, string arrays. Let's do this. Let's open up month, days. So look at this. I've got string, left and right square bracket, months equals January, February, March, April, May, all the way through December. Okay? So it's got 12 elements in that array. Then I create int, left and right square bracket, days, and now this is an integer, and I've got 31 through 30, so basically 12 different elements there, the number of days per month. Now, this is what's known as parallel arrays. This element, the number 0 element, goes with this 0 element. Number 1 element goes with the number 1 element, so on and so forth. They're parallel arrays. So I come in here for my for loop, and I say for int index equals 0, while the index is less than months dot length. Again, the dot length is the number of elements in the array. At the end of the array, I'm going to add 1 to the index. So I say months index has days index days. So it's going to display the month name has the number of days, the days array, and then the word days after the end. So when we run it, it basically just has January has 31 days, February has 28 days, March, so on and so forth. So pretty simple string, just like other data types. We can basically make an array out of that. Page 444, we've got array of objects. Okay, so guess what we can do there? Let's open up object array. Now let's take a look at this guy. This is pretty cool. So we've got a bank account. Let's open up bank account first. So here's my bank account, and it's just a class. So we've got a, I think it's pretty much the same bank account we saw last week. So it's got private double balance. So there's my instance variable. Here is my constructor bank account. We're going to set the balance equals 0. Look at this. We're overriding the constructor because it's going to look inside the parentheses and look at the signature. This is a no argument constructor. This is a double constructor, double signature constructor, and this is a string signature constructor. So depending on how we initialize our object is going to depend on which constructor gets called. Now, not all 3 constructors are going to get used. Only one of them will get used, and the other 2 will not be used at all. Okay, so we go back to the object array. So here's my bank account accounts. Well, first of all, I've got a constant num accounts is equal to 3. I got bank account accounts is equal to a new bank account num accounts. Wow, what's going on here? Look at this. See the square brackets? I'm creating an array of bank account objects. How many elements are going to be on my array? 3 elements. So when I get through with line 17, I now have an array it's basically got 3 bookshelves, and each bookshelf is going to hold an object, a bank account object. The name of the array is called accounts. I'm going to then call create accounts, and I'm going to pass the accounts array to that. So I come down here to create. So here I am receiving my bank account array called array. I've got double balance. Here's my scanner keyboard, and I'm going to go into that array by the number of elements, and I'm going to say enter the balance for account index plus 1. Again, I wanted to say 1 and not 0. I want to have it say 1, 2, 3 instead of 0, 1, 2. And I'm going to get that from the next double from the keyboard, put that in a balance. Then I'm going to say array index is equal to new bank. Look at now. This is kind of wild. I say array index is going to be instantiated as a new bank account object. I'm going to pass in balance. And what is balance? Balance is a double, so it's going to then instantiate this with the double signature, it's going to call this guy and say balance is equal to start balance, whatever's passed in. So there's my first element of my bank account array. When I come back around, it says enter the bank account. We get the next double, and now, look at this. The next element of the array is going to be instantiated as a new bank account object, and we're going to pass in that balance. Next time around, so it's going to keep doing that. When I get done with this for loop, I now have an array of 3, is it 3? Yeah. I'm going to have an array of 3 bank account objects. Down here, I'm going to say here are the balances for each account. I'm going to go into that for loop again, and it's going to say account. Again, I do index plus 1 because I want to say 1 instead of 0. And it's going to put a $, accounts index dot get balance. We're going to get that balance back for each of those. Again, it's an array of bank account objects. So let's run it. And let's go ahead and balance for 1. We're going to say 2,500. Bank account 2 is going to be 5,000. Bank account 3 is 1,500. And when we get done, it says here are the balances for each account. 2,500, 5,000, and $1,500. Any questions on that? So we can create an array of pretty much anything we want. We can create an array of primitive data types. We can create them from strings, or we can create them from objects that we created. So class objects that we create, we can basically create an array of those things as well. On page 447, the concept of this is we literally have in a real world situation, it's more used in the database world, but we need to search for something. And first thing we'll cover is just a simple sequential search. And that's really all it's doing. It's just a sequential search. It's just going to open up something and go line by line by line, searching for that particular item. Okay? And that's really all this is. It's an algorithm just to do a search. So let's open up search array. And here's what we got. So inside of our public static void main, we're going to create an array called tests. They're integers, and we're going to initialize it with 87, 75, 98, 100, and 82, which is 5 elements. So it's got 5 elements in this array. We're going to create a variable called results. It's an integer. We're going to say results is equal to sequential search test. So here's the array and 100. So we're going to call this method sequential search. We're going to pass the array and the number 100. So we come down here to sequential search. So here we are reading in the int array. See the left and right square brackets, and then int value. We're going to create 3 local variables: int index, int element, and boolean found. Notice right here we are returning an integer. We're going to set the index equal 0. We're going to set element equal -1. We're going to set found equals false. That's going to say while not found, okay, and index is less than the array.length. So while this is true, found is true, found is false. Okay. If the array index is equal to the value, so we're going to go through this one element at a time and see if it's equal to 100. That's what's in value here. We're going to say found equals true, and element equals index. Okay. So we're going to make the index. We're going to make this element equals the index. So whatever the index is going to set to element. So when we get done with this for loop, element is if we found the item, it's going to have -1 in there, or it's going to have the item in there. So return element. So it comes up here and it says if so results gets passed. So whatever we've returned gets passed to that. If results is equal to -1, that means what? We did not find anything. We're going to print you did not earn 100 on any test. Else we're going to say you earned 100 on test results plus 1. So again, remember we wanted to say the number of the tests. So if we got 5 tests, the elements are 0, 1, 2, 3, 4. We wanted to show that we're going to show the results of test number 3 instead of test number 2. Okay. So that's pretty much what we're trying to show you here. Is we're going through sequential search. We're just going item by item by item by item. So if we run this, it says you earned a 100 on test number 4. So if we look up here, so there's 0, 1, 2, 3, 4. But remember, we add 1 to it, so it's 1, 2, 3, 4. Test 4. I don't know where those colors just came from. I clicked and dragged on something and got some weird colors showing up. Okay. Let's just cover one more section. We're going to cover 2-dimensional arrays, and these are kind of weird because think of it kind of like what I want you to think of a 2-dimensional array is think of it as an Excel spreadsheet where we've got columns and rows. And so let's do this. Let's open up corpsales.java. How did I get that color on there? Oh, I have to figure that out. I clicked on something. Okay, so let's take a look at this. In my public static void main, I've got 2 constants, divs and quarters. So I got divisions and quarters. And then I create a double total sales and I initialize it to 0.0. Now let's take a look at this. I got double, left square bracket, right square bracket, left square bracket, right square bracket. I got 2 of those side by side. Sales equals new double, divs quarters. Oh. So what we just did here is we created a 2-dimensional array. So what I want you to think about is think of the divisions are the rows and the quarters are the columns. So we're going to have 3 rows and then 4 columns. I've got my keyboard, scanner keyboard set up. It says this program is going to calculate the total sales of all the company's divisions. Enter the following sales data. Now, notice here I've got a for loop inside of a for loop because that's pretty much what we want to do. We're going to do the row, we're going to do it by row, and then we're going to do the quarters by row. So we're going to go into the first division, which is 0. Then we're going to go through all the quarters. So quarter 0, 1, 2, 3. And we're going to say division. Now look like we're using a printf here. Division D, quarter D. So there's div plus 1 and quarter plus 1. Because again, we want to say division 1 or div 1 and quarter 1. We don't want to say div 0, quarter 0. That's why we add the 1 to it. and then we're going to ask the user to type in the next double, and we're going to put that into the sales div quarter. So row 0, column 0. Let me see if I can make this a little simpler here. So this is kind of what we're doing. When I've got these, like say down here, I've got a new double 3, 4. It's basically created this two-dimensional array. And this first box is score 0, 0. The next one is 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. And that's basically what we have for our divisions. We've got, so these are divs, these are quarters. So we're going to have our sales, division 0, quarter 0. Division 0, quarter 1. Division 0, quarter 2. Division 0, quarter 3. So we load it on line 37 here by, so again, think of this like a spreadsheet. Whatever that number is, it's going to go in that slot. Then we're going to do a println to print a blank line. Then we're going to loop through it so we've got a loop inside of a loop. We're going to go through the divisions, each row one at a time. But inside of each row, we're going to display each quarter. Here's the total sales, sales div quarter. So first time through it's 0, 0, then 0, 1, 0, 2, 0, 3. 1, 0, 1, 1, 1, 2, 1, 3. 2, 0, 2, 1, so on and so forth. And then we're going to display, so right here, that's what this guy's doing. This guy is taking the sales from each element and adding it to total sales. And then down here we display the total sales. Let's run it. And here's division 1, quarter 1. Let's just type in 3,000. Quarter 2, we're going to say 2,500. Quarter 3 is 3,300. Quarter 4 we'll say is 6,000. And then here's division 2, quarter 1. We'll say 1,000. We'll say 2,500. We'll say 1,500. And we'll say 4,000. The division 3, quarter 1, we'll say is 5,000, 1,200, 3,000, and 1,000. We get done. The total company sales were $34,000. So if we go through and add all those up, does that make sense? Can we do 3-dimensional arrays, 4-dimensional arrays? We can, but man, those things get so complex, it's not even funny. It's not even funny how complex those things can get. We can get the lengths, so let's open up lengths.java. So here now look how we can initialize a 2-dimensional array. So we've got open brace, and then for each, so that's the overall, and then you notice we've got row, 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 and then inside of each row is column, 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 column. So we've got 3 rows and 4 columns. So I got open brace, and then each open brace is for each row, and then a closing brace to show the overall close of the array. The number of rows is numbers.length. That seems kind of weird. Numbers.length. That's going to show the number of rows. Display the number of columns in each row. So we're going to go through each item. And we're going to say, so index equals 0. Index, well, index is less than numbers.length. So the length. So notice that it defaults to the number of rows and not columns. Well, that's because you can't look at it. Looks at the rows before it looks at the columns. So when you get the length, it's going to grab the number of rows. And then we go through each one of these. Say the number of columns and row index is numbers index.length. Ah, look at that. So when I say numbers index.length, notice I'm grabbing just one index. When I grab just one index, I'm looking at the entire row. And when I do a dot length, it's going to tell me how many columns are in that row. So it's kind of tricky here. When I do dot length, that's going to show the number of rows. When I grab the just one index, when I use just one index, that's actually pointing to the row. And when I do a dot length, that shows the number of columns. So I run it. And the number of rows is 3. The number of columns in row 0 is 4. The number of columns in row 1 is 4. The number of columns in row 2 is 4. On page 459, we've got to pass a two-dimensional array. So let's look up pass 2D array. And here we initialize a two-dimensional array. Notice we've got the two sets of square brackets. We've got the braces inside of braces. So there's row 1, row 2, row 3. So it's a 3-row, 4-column array. It says here are the values in the array. I click show array, and I'm going to pass the two-dimensional array to that. So I come down here, notice I've got int, two sets of square brackets, array, because it's a two-dimensional array. And then I'm going to have for loop inside of a for loop. Int row equals 0 while row is less than the array.length. Again, that's going to show the number of rows. And I'm going to say for int col1 while the column is less than col row.length. So then again, remember, when I grab just one, when I use just one index, that basically shows the row, and the dot length is going to show how many columns we have. Then I come in here and say print array row column, and then I'm add a space, and then I do a print ln to print a blank line. So we should have, so what I expect to happen is it's going to show column, 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 drop down a line, column, 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 column. I keep doing that. So that's what show array is going to do. Down here I'm going to say the sum of the values is array sum numbers. So I should be expecting a return here. This should return something. So when I come down here, sure enough, there's array sum. It's going to turn an int. We got an int total equals 0. Again, we go into the same exact for loop. We're going by the length, which is number of rows, and then the row itself dot length is going to show the number of columns, and we're just going to do total plus equal array row column. So it's going to grab each element out of each column for each row and add it to the total, and then we return total, and it's going to display that right here. Pretty simple. Run it, and here are the values of the array: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the sum of the values is 78. Okay. Next week we're going to start with on page 462. Well, Now, I tell you, we'll just touch on a three-dimensional array. We'll just look at it, but I don't want to really go too far into that. But just realize we can go three-dimensional, we can go four-dimensional, we can go again. Those would be so complex and hard to read and understand that it would not be worth it. But we'll start on page 463 and then finish the chapter and then answer any questions you guys might have, and we'll call it a night. Anybody have any questions before we break? Okay. Okay, guys. We'll see you on Thursday. Have a good night.